So now that we've discussed where on a graph a function is not differentiable, uh, I do want to expand on that a little bit with an extremely useful idea to keep in mind when you're working with differentiability. And that is that differentiability implies continuity. So if a function is differentiable, in other words, a derivative exists at a specific point, then the function is continuous there. And this actually comes from the contrapositive of that statement. It says if f is discontinuous at a point, as we already know, then the derivative does not exist there, because that's one of the four places a derivative cannot exist on a graph of a function. So because contrapositives always have the same truth value as original conditional statements, this means that if a function is differentiable, then it must be continuous. And this is wonderful for us because then if we see or we are told that in some way that a function is differentiable over its entire domain, we can assume that the function is also continuous then. Because if we're told a function is differentiable, that implies the function is continuous. One thing that's important to keep in mind, though, is that the converse is false. If a function is continuous, it is not necessarily differentiable. In fact, if a function is continuous, we cannot really say whether a derivative has to exist or not. We would have to look at it on a case-by-case basis. And that means that it's nice to keep in mind a particular example. For me, I like to remember absolute value functions because an absolute value function is continuous but not differentiable due to a corner. So, because remember, corners, cusps, and vertical tangents all happen on continuous functions. So remember, derivatives, if a derivative exists, the function must be continuous. But if a function is continuous, it is not necessarily differentiable. It might be, it might not be.